Before we are now getting to the actual implementation, let me get the elephant in the room out of the way. That is understanding the ERC721 token. Now, if you've already looked into the ERC721 token, then there's probably nothing new that I'm going to tell you. It's basically an ERC20 token where each of the tokens has a unique ID and can have a URL for more metadata. Now, if you look at this ERC, or actually EIP 721 on the ethereum.org website, then the simple summary actually summarizes it all. It's a standard interface for non-fungible tokens, also known as deeds, because it actually has its roots in real estate deeds, which is a big misconception that like the NFT metadata, for example, should be immutable. It should not, because when you are looking at real estate deeds, then they can change. So the metadata needs to change. And it's just who owns that particular apartment, real estate, or whatever it is transferable, but the metadata then also needs to update, or maybe can even be extended. A good practice is to put the metadata, which is just a regular JSON file, somewhere on a regular host, but it doesn't have to be. It can also be immutable if your token requires that. So it's up to you to actually set that. You see here the standard ERC721 interface. You see probably a very familiar transfer approval events. They just have an additional token ID at the end. So everything that belongs to a specific token, like transferring it or allowing it to spend, is for a specific token ID. It's like deploying a separate ERC20 contract, which is then just having one token to a separate address, but instead of having several different addresses, you just have it in one address with one smart contract who can deal with token IDs. Now, the other token, which we are going to discuss probably another day, is the ERC1155 token, which is then an NFT where each of the tokens can have several amounts in addition. Like each token ID can have several ones of the same token ID. But let's stick with the ERC721 token for now. The other thing which is confusing to a lot of people is the token ID itself. The token ID, if I can find it, the token ID is identified by a unique uint 256. So it has to be a uint 256, which shall not change for the life of the contract. So you cannot just have a token ID 1, which suddenly becomes token ID 2, which also means that the pair address and token ID is then a globally unique and fully qualified identifier for the specific asset on the Ethereum chain. It doesn't have to start with 0. It doesn't have to start with 1. It doesn't even have to be consecutive numbers, but it may start with the ID 0 and simply increment by 1 for each new NFT. But you shall not assume that ID numbers have a specific pattern to them. It's important to understand that. The other thing is the metadata choices with the metadata extension. It's a mechanism to have metadata URIs or URLs associated with NFTs. The image sizes are taken from the image sizes from Instagram at that time, so that might have changed now. So you're not really bound to that. It's more like a recommendation, and the URI may be mutable. It doesn't have to be mutable, so it can change from time to time. They have considered an NFT representing ownership of a house, and it might be metadata of the house, like an image, occupants, that can naturally change. Now, enough of the theory. Let's get into the practice. Let's have a look at one sample NFT. So I have OpenSea opened here, and I have the RTFKT Collection, which was, I think, recently bought by Nike. And I have Token number 4 here, the way you identify this is OpenSea.io/assets/Ethereum, and then the token address, and then the token ID. And number 4, when you look at this, you have a couple of properties over here. One is you have an image or a video in this case. You have a name, belongs to a collection. You have a description. There's some properties like artifact socks, collection genesis, and then you have an about section of the artifact collection itself. And then some more data like sales data, which is unique to OpenSea. Now, where's the data coming from? If we are opening that very address on Etherscan, which I have here, and then we are going to read the contract, and then we are looking at the token URIs for token number 4, then you will get an IPFS hash. IPFS, we haven't really talked about it yet, but IPFS is a distributed file system that is immutable in this case. So when you upload a file, it will create a hash of the file contents of itself, and then you get this back as a URL. IPFS is a protocol, but there are gateways, so you can actually read that without installing any node. And one of them would be IPFS.io/IPFS, and then the whole URL as over here. And what you get back then is a JSON file. And the JSON file has the exact same contents as the content over here on OpenSea. This is where OpenSea pulls the information from. It's as simple as that. Now, in order to create our own NFT, I was thinking about, giving you instructions to upload the JSON file somewhere, but then I thought, come on, we are Web 2 developers. You probably have seen JSON files before. You can probably upload them. For convenience, I'm just going to host a couple of JSON files and a couple of images. So I created 4 images with DALL-E. This is number 1, spacebear 1, 2, 3, 4, and we are going to create a new token called spacebear token. So I'm also hosting the JSON on ethereum-blockchain-developer.com / this current project /NFT data, and then spacebear _1, 2, 3, 4.json for token number 0, 1, 2, and 3. How do we create these tokens? There's a couple of ways to do that. And the easiest one is probably to use the contract wizard from OpenZeppelin. Now, if you open the contract wizard on docs.openzeppelin.com/contracts/4.x/wizard, over here in the wizard section, then we already worked with the ERC20 token. Now let's get the ERC721 token running. We could name it spacebear, and then maybe call this SBR. And then as a base URI, we have HTTPS ethereum-blockchain-developer.com / what I just told you, the whole URI without the spacebear 1 JSON. I just paste this over here. It's going to be mintable, so the only owner can mint. There's also auto increment IDs, what I said before. The ID doesn't have to start with 0, but for convenience, it's going to start with 0 and it's going to be incremented every time we do a mint. And it has an URI storage, and the URI storage over here just allows you to specify during the safe mint URI for the one token that you're doing. Otherwise, it would be this URI, so the base URL /1 without /0, actually the token ID. But if we want to have a different token URI for each token, then we can do this that way. So that's it. That's it. So we are going to copy this to clipboard. We are going over to Remix, and we are going to create a new file, and we are going to call this spacebear.sol. And let's paste this. This doesn't work. I know this. This didn't work before, and now it still doesn't work. You could open in Remix if you want, but then this will open the HTTPS Remix, and I don't like it. So I'm just copy and pasting like this. And then we need to deploy this somewhere. and mint the token and then see if it pops up correctly on OpenSea. Okay, it's compiling correctly. That's a good thing. Now let's head over to the Deploy and Run Transactions tab. Let's keep it in the Remix VM, just quickly test everything if it's working. Deploying and then minting. And let's mint a token for myself. Save mint. And then the URI is going to be space bear_1.json. And then let's see if the token URI for token 0 is the right one. Yes, that's the whole URI. Just copy and paste it over here just to see if it really works. Yes, it works. And then from the metadata, it's going to get the image, which is this one. And then it's going to display it on OpenSea, at least in theory. Let's see if that works in practice. So OpenSea has 2 testnet implementations, at least at the time of recording this video. The one is for Rinkeby, if I'm not mistaken. The one is for Rinkeby, which doesn't work very well. And the other one is for Girly, which works better. I know in the previous videos, I have used Kovan to deploy smart contracts, but Kovan at the time of recording this video after ETH 2.0, after the merge, is going to get deprecated. So, and it's going to be shut down probably. So I'm recommending at this point to use Girly going forward. If you have no test ETH for Girly, then go back please to the test ETH, get test ETH section. I'm trying to have a faucet in there which actually works. If you still cannot get it done, then ping me somewhere and maybe we get something up and running. I also have only limited amount of Girly ETH. I'm usually trying to get them from somewhere. I have 0.47, more than enough to deploy this token. So if you're going to deploy this token now, deploy on Girly, send the transaction. Takes a little bit. Let's view this on Etherscan. It's still pending. Okay, we have our transaction done, and now let's mint one token. Well, for myself, I like to have these tokens to myself. Space bear1.json. Hit transact and sign that transaction. And then we can take the contract is not going to be verified here, and I'm not going to verify this contract. But what we can do is we can take the contract address over here, copy it, and then you go to testnets.io/assets/girly/your address/0. I mean, not your address. I meant the token address, of course, not your own address. And what will happen is that it will pull the metadata and it will pull the image from the Ethereum-blockchain-developer service based on the metadata URI that is in the token. And it will show it on the website. And now you could sell it, basically. That's how it works. There's a lot more to it, of course, like secondary sales commissions. And I have a separate section on that as a free mini course on Ethereum-blockchain-developer.com, which is not part of this tutorial. It would exceed what we actually want to achieve. We want to achieve to bring our development environment offline, and we are going to start with Truffle now.